All right. Hello, everybody. I hope you guys are doing well today. I gave myself a quarantine haircut today, and I don't know if you'll even be able to tell, but in the back, it's totally uneven. I think this side is much longer than this side. So we'll have to get that fixed eventually. We'll see how that goes. Okay, so anyways, fun stuff for today. It's just hair, right? I did cut it way shorter than I intended, but whatever. Okay, so today we're talking about the applications of trig functions. So we are doing some modeling, which is super fun. So we're going to talk about pendulums, blood pressure, and we have a clock problem on the back. And then for your practice today, we're going to do some Ferris wheel stuff. I think I'm going to do one of them for you and then have you guys do the other one. So that's the plan for today. We're going to start with our notes. Okay, so it says a pendulum swings in a museum at rest. It hangs 9 feet from the nearest wall. So this is where it hangs, 9 feet from the nearest wall. The pendulum swings 4 feet away, so 4 feet this way from this place. So 4 feet is right here. And then back through its resting position, and then 4 feet towards the wall. It takes 6 seconds for the pendulum to swing from its farthest point from the wall to its closest point to the wall. So it says find the following key features. If you are unsure of your answers, it may help to graph some of the points on the plot below. Okay, so the first thing we want to do is it says to find the maximum distance from the wall. Okay, so the maximum distance from the wall we know isn't here, right? Because it can reach all the way over here. But right here, it is 9 feet from the wall, okay? And then to get here, which is the maximum distance, we get 13 feet from the wall because 9 plus 4 gives us 13. Okay, now it says the minimum distance from the wall. That's going to be 4 feet closer to the wall than it is when it's at rest. At rest, it's 9 feet from the wall. Then we move 4 feet to the left. 9 minus 4 should give us 5 feet. Okay. Then it wants the midline. So this midline is going to be when it's at rest. Okay, so this occurs right down the middle. Okay, so it's halfway between the highest and the lowest point, and we already were given that that's when it's 9 feet from the wall. Okay, so those three hopefully were pretty easy. So now we need to transfer these three concepts of being farthest away, closest to, and in the middle relative to the wall. We need to translate those into the pieces of our function. So it asks for the amplitude. Now the amplitude, if you remember, is halfway between the max and the min, or the distance from the max to the midline, or the distance from the min to the midline. So in either case, this is going to be this 4 units right here. Okay, now the period is going to be a little bit harder to, it could be a little bit harder to see. So I want to go ahead and graph some points. So we know that, let's see, the pendulum swings 4 feet away. We're going to say that it starts at the midline. It swings farthest away and then goes close to the wall. Okay, so if we're starting at the midline at zero, at time is 0, that means our first point must be at this 9-foot mark on the left there. Let me zoom in a little bit so you can see. Okay, so this is going to be our very first point on the graph. Then our next point is going to be at 13 feet, okay? And it tells us, let's see, we need to see how long it takes to get here. It tells us it takes 6 seconds for the pendulum to swing from its farthest point from the wall to its closest point. So to get from here to there takes 6 seconds, okay? So if we're just going from here, oh, I'm sorry. From here to there took 6 seconds. But if I'm just going from here to there, okay, if I'm starting at the midline going to the farthest, it should take me half that time. So it should take 3 seconds. So I'm going to count 1, 2, 3 at the bottom and go up to 11, 12, 13. So this should be my next point. Okay. Then 3 more seconds to get back to the midline. So at 6, I should be back at 9. Okay, so now it took me 3 seconds to go from here to there, 3 more seconds from there to there. Okay, and then we would want to keep going. Our closest point to the wall should be 5 feet away. So if I move 1, 2, 3 seconds more further to the right, and then scroll up to 5, I should put a point right here. Okay, and then 3 more seconds away, 1, 2, 3 should put me at this midline again right here. So I'm going to go ahead and draw in that. Okay. So that is my first little cycle of my pendulum. Okay. I started at the midline. I went to the farthest point away, got back to the midline, then closest point back to the midline. Okay. So I started and ended at the same place. And I went through both my max and my minimum. Okay, so let's look at how long it took us to do this. So if I look at the end of this point, I went 10, 11, 12 units. So my period should be 12 units of time, I think seconds. Okay, and if you notice, that's double of what this was. Okay, so we started here. It took 6 seconds to get there, and it's going to take 6 more seconds to get back to the beginning, which is where we started. Okay. Now the B value, remember, we find there. I'm going to actually write this at the top. Our period is equal to 2 pi over our B value. Okay. We can rewrite this as B is equal to 2 pi over my period. Okay, and this equation is going to be easier to use when you're solving for your B value. So we're going to use that for part F, but these two equations are the same. Okay, and you can use either one depending on what information you're looking for and what information you're given. So I'm going to go down here. My period we know is 12, and I'm looking for my B value. Okay, so I have B equals 2 pi over 12. 2 pi over 12 should reduce to pi over 6. And that would be my B value right here. Okay, so there's that. Then it asks, does the function start at a maximum, minimum, or midline? Our function here started at the midline. It started when it was at rest. And it says, should the function be sine or cosine? Because it starts at the midline, it should be a sine function. Okay, then it says write the equation. So I'm going to use, let's see, yesterday I used pink, yellow, and green, I think. Oh, I should really look at those notes so that I can. Okay, so my B value is going to be my green piece. Okay, my midline was my pink piece. And then my amplitude was my yellow piece. And I'm going to fill in the equation exactly like you had it on your notes. So we have 4 sine of pi over 6x plus 9, and it needs to be an equation, so I have to have like equals y. I could have put that at the very beginning. And then, let's see, my amplitude was my yellow piece from the notes. My midline was the pink piece from my notes, and my period or my B value, which comes from my period, was the green piece. And this is from the equation A sine of bx plus d. Okay, and that is what we did yesterday in our notes. And these were the colors we used to represent those values. Okay, so that is number 1. Hopefully the pendulum and the periodic motion of a pendulum makes sense to you. It's going to swing back and forth from its max to min and hit the midline in the middle every time. Okay, so let's move on to number 2. It says blood pressure is measured in millimeters of mercury and can be represented with a sine graph. The graph below shows blood pressure of a person whose blood pressure is 120/60 and whose heart beats once every 0.75 seconds. So it says first find the maximum. So our maximum should be 120. Okay, we see it hits that over and over again right here, here, there, and that number is 120. The minimum should be, it's like halfway between 40 and 80, so we'll call it 60. Okay. And then the midline should be halfway in between those two pieces. And we're going to call that 90. So if I take 120 and subtract 60, I should get 60. Okay. So 60, wait, let me make sure I'm doing this right. And then we would want to divide that by 2. So divide that by 2. And that's half the distance that I need to go either from the max or the min. So this gives me 30. So I can start at my minimum, which is 60, and go up 30 to get to 90, or I can start at 120 and subtract 30 to get to the 90 from that direction. Okay. So this is what we add or subtract from the min or the max. I can't write. From the min / max, respectively. So we would add it to the min, subtract it from the max. That's what the respectively means. It means to like correspond to those pieces directly. Okay, so now we need the amplitude. So the amplitude is how long or how far it takes to get from the midline to the max or the midline to the min. Or you can do what we did here and just like divide that the distance between the two in half. So our amplitude should be 30. It tells us that the heart beats once every 0.75 seconds. So this is our period. Okay. So every beat is one cycle that gives us one period. It tells us that's 0.75 seconds. So to find this B value, so we know that our B should be equal to 2 pi over 0.75. I'm going to rewrite 0.75 as 3/4. Okay, so then this can be rewritten as 2 pi times 4/3, which is 8 pi over 3. Oh, you didn't see that at all. I'm sorry. So I rewrote 0.75 as 3/4, which then can be written as 2 pi times 4/3. Because I flip the denominator up, I like do the keep, change, flip thing. And then 2 times 4 is 8. I still have my pi, and then 3 is in the denominator. So my B value is going to be 8 pi over 3. If that confused you and you're just like, nope, I have no idea, you can put it into Desmos and it will do it for you. Just leave out the pi, put 2 divided by 0.75, click the little fraction thing on the left-hand side. It'll turn it into 8/3 for you and just tack the pi on in the numerator, okay? So then it says write the equation for the sine function. So we have y equals, the first thing we want is our amplitude, which is 30. Oh, I should definitely write before I highlight. Then we need our sine value. Then we need our B value, which is 8 pi over 3. And then we need to add on our midline, which is 90. Okay, and we're done. All right, so that was pendulum and then blood pressure. And then our very last one is our clock.